Good morning, everyone. Am I audible?
Yes, sir. Good morning, sir.
Good morning. Yeah. So please keep your video switched on. Everyone? Yeah. Ananya, good morning. Chitesh, can you keep your video on? So my voice is clear, right?
Yes, sir.
Okay. So what was the last concept we were discussing? Chitesh, I think you missed the first few classes.
Intervals, sir.
Yeah, sir.
Yeah, did you get a
Intervals and
chance?
power sets.
1 minute. So it was power set, right? No, Venn diagram we saw.
Yeah,
I think
yeah,
we saw.
yeah. Venn diagram we just saw, yes.
Yeah. So Chitesh, you missed a few concepts, right? Like I think you joined late, but did you get a chance to go through the videos? Okay, if you have any doubt, no, reach out to us.
Yeah, sir.
Okay, yeah.
Yeah.
So apart from that, any other questions, guys? Any doubts that you had? So I think it is easy as of now, right? So having said that, we'll proceed. So you're able to see my screen. Yes. Yeah, Venn diagrams, and I think last concept that we saw was this definition number 6, which is related to the union of sets. Am I right? Balaji, am I right?
Yes, sir.
Yeah, this is what I remember. Okay. So just to recollect, so what are the different operations that are possible on sets?
Union, intersection.
One minute.
Excuse me, sir. Did you say anything? I didn't hear it.
No, I didn't say anything. I just told. Give me a minute. Just have some important message to respond. Yeah. As you were saying, yeah, union, intersection. These are all the different operations on sets, right? So what do you mean by union of sets? As the name said, is union means you're combining some. So if I give you two different sets, right? Those two different sets are going to have different values present in them. Am I right? See, for example, let's take this example number 12. A is equal to, let's say you have 4 elements, which are 2, 4, 6, and 8, and B has 6, 8, 10, 12. Then find A union B. If somebody, so U stands for the union, right? So if they ask you to find A union B, what are we going to do? Ananya, can you
pick out the elements from set A and set B, but not the repeated ones.
Yeah, that's right. Ananya, can you tell me what is going to be the answer? So it is going to be.
We have to take the elements from set A and write it down. Then the same, if the element is repeating from set B, then we should not write it again.
Exactly.
We should take the element and the other elements we have to add. So it
Okay.
is 2, 4, 6, 8. And
Okay.
since 8 is repeating in the other element, we should not write that. We have to write 10 and 12.
Perfect. Perfect. Chitesh, I hope you could understand this, right? So it's very simple. Actually, we have 4 elements here and 4 elements here. Union speaks about combining both. We expect 8 elements, but how many are coming in the output set? There are only 6 elements, right? Because of the repetition. Now, example number 13. So Chitesh, can you try telling this? I have a set A which is AEIOU, B is equal to AIU. Can you tell me what is A union B?
So we already have, we have to write AEIOU first. And
Okay.
since it's all repeated in the first one, we can just write the first one and express it as A union B.
That's right. So in this case, what is happening is A union B is coming out to be AEIOU, which is nothing but the set A itself. That's what they have asked. Right. So it is very simple again. Next. Now, example 14. Balaji, you tell me. So X is equal to Ram, Geeta, Akbar be the set of students of class 11 who are in school hockey team. Y is equal to Geeta, David, and Ashok be the set of students from class 11 who are in the school football team. Now find X union Y and interpret this.
X union Y is equal to collection of Ram, Geeta, Akbar, David, Ashok.
Ram, Geeta, Akbar,
David, Ashok.
David, and Ashok. So who is present in both the sets?
Geeta.
So that's why you wrote it once, right? Now, with all these examples, let's see how to represent the union in terms of a diagrammatic format. Now we saw with elements, right? We'll see how to put it in a diagrammatic format. So the union of two sets A and B will give us a new set. See, I want you to think in these terms, okay? Whether the output is going to be an element or the output is going to be a set. That is what we need to always focus on. This is where these are the minor points on which we need to focus. So what is happening? If I give you one set A and another set B, I ask you to perform the operation of union between them, then you will get an output which is a set itself, right? So the union of two sets A and B is a set C, which consists of all those elements which are either in A or. So if you have the word or, what is operation we perform? We perform union. So which is either in A or in B, that is including those which are in both. Then how do you write it? We write it as A union B is equal to, in the set builder form, how are we going to write? We need to write only those elements. We need to write only those elements X such that X belongs to A or X belongs to B. This part I want everybody to make a note of. Please write it down. So let me know once you're done copying it.
Done, sir.
Done, everyone? Balaji, where is that guy? Ananda, what is his name? Anand, no? Any idea?
Ashwin, sir.
Ashwin, yeah, Ashwin.
No, don't know, sir.
Not sure. Okay. Shall we proceed? Now see. So for you to represent it in the form of a Venn diagram, so Venn diagram consists of what shapes? Two important shapes. What are they? What are they? One is a rectangle and the second is circle. So the rectangle is going to represent the universal set. So the rectangle is going to represent the universal set. And inside that, let me consider a circle and give it a name A. What is the meaning of it? I have a set A. Similarly, I'm taking another circle and calling it as set B. So here what is happening as per the diagram? They both are intersecting each other. See, if suppose A is like this, B is like this, they are not intersecting. Here what is happening? They are intersecting. So they have the common elements. So that's what we did in the examples. We need to remove the common elements. So if I ask you, what is A union B from this, what will you write?
We should write in the form of set builder, sir.
Okay, 1 minute. If I ask you what are the number of elements in A union B, what will you write? Small n stands for number. You read it as number of elements in A union B. Then it is going to be number of elements in A plus number of elements in B. Right? But what will get removed?
The common elements.
Yes, because in A and B, you already have the common elements. If you include them again, you'll be writing them twice. So to eliminate that, what we do is we eliminate them. So you write it as minus number of elements in A intersection B. About this, we'll learn after the concept of when intersection. Intersection is basically inverted U. I hope you're able to get some perspective out of this, right?
Yes, sir.
So let's see what are the properties that are followed with respect to the operations on union. So first thing is A union B is the same as B union A, which is called as commutative law. Similarly, if I perform A union B first and I perform so A union B is going to give me a set. Let me call that set as D, for instance. So if I perform the union of that output set D with C, it is the same as performing A union B union C. That is, I first perform the union operation between B and C, and then I take the union with A. So they both are same. This is what is called as associative law. Similarly, if I take the union of a set with null set, what do I get?
We get the set itself.
We get the set itself because null set has no elements. Right? So law of identity element. So null set is the identity of U. So this is called as the law of identity element. And what is that identity element? It is a null set. Okay. So A union A, if you do the union of a set with itself, what do you get? You again get the set itself. Okay. If you do the union of the universal set and the set A, what will you get? You will get the universal set. So I think I mentioned this point already. Whenever you're doing the union, you will always get a bigger set. Bigger set than whom? Bigger set than the individual sets. Or at the max, you will get the set itself. But you will never get a set lesser than the sets that are participating in the union operation. There's a point to be noted. Right. Now we are going to see the next one, which is called as the intersection of sets. So intersection, as the name suggests, right? When I speak about intersection, I take the common elements, right? The intersection of set A and set B is a set of all elements which are common to both A and B. This is very important. Whenever you see the keyword and, we need to perform intersection operation. Am I clear with that?
Yes, sir.
Of this point first. So the intersection of sets A and B is going to give you another set. And what will that set contain? It contains all the elements from A and B which are common in both. Am I clear with this? Please make a note of this point. Write it down. Okay. So what is the symbol used for intersection? It is an inverted U. It looks like an inverted U. So this is the symbol which is used for intersection. The intersection of two sets A and B is going to be the set of all elements which belong to both A and B. So symbolically, this point I want you to write it. So symbolically, how are you going to write it? A intersection B is equal to the set of elements X such that X belongs to A, and underline this word, and X belongs to B. Clear with this?
Yes, sir.
Okay, now listen. So they're saying consider the set of example 12. So 2, 4, 6, 8 is there, 6, 8, 10, 12 is there. What are we supposed to do if they ask you the intersection operation? Take the common elements and write a set. What are the common elements?
6 and 8.
6, 8.
That's it. So the set is going to be, where is it? 6, 8. Simple. Similarly, if you take the example number 14, that Gita thing, no? So what was the common element?
Gita.
It was only Gita because she was there in both. I don't remember. One
Set
is football.
A and B.
One is
X
football
and
and
Y.
hockey. So she is there in both the sets, both the teams. So example 17. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is equal to 2, 3, 5, 7. A intersection B. So what is the A intersection B? Obviously 2, 3, 5, and 7. So if you did you observe one thing here? When you do intersection operation, you are always getting a set whose size is
Small.
less than which are participating in the operation. You always get a smaller set. Right? So since you have already understood the Venn diagram part, what I will do is I'll explain the Venn diagram situation here. So again, I'm going to take the universal set here. Let's say I take set A and set B like this. Right? I take set A and set B like this. Then if they both are intersecting, then this region is going to give me the A intersection B point. Am I clear with this?
Yes, sir.
So this is going to be the A intersection B part. Shall I proceed?
Yes, sir.
So we will see some properties that are related to the operations of intersection. One is A intersection B is the same as B intersection A. Similarly, which is again commutative law. Is it going to obey the associative law, that is A intersection B intersection C? Is it the same as A intersection B intersection C? Yes. Okay. Third, if you do the intersection of a null set and A, what will you get? You will get the null set. If you do the intersection of universal set and A, what do you get? You get A. You always get the smaller set. If you do the intersection of A with itself, you'll get the set itself. Right? Similarly, this one is a very important point. Right, till here, make a note. I'll explain the last point at the end. So write down the heading as some properties of operation of intersection.
Done, sir.
Okay. So look at the last point, no? A intersection B union C. Here it is a combination of intersection and union. A intersection B union C is the same as A intersection B union A intersection C, which is called as the distributive law. That is, that intersection operation is getting distributed over the union operation. It's a very, very important point. Make a note of this. So the intersection operation gets distributed over union. Am I clear?
Yes, sir.
Listen. Now what I'm going to do is we are going to see the Venn diagrams, right, for different set. See, I have the universal set. The rectangle is universal set fixed. Now, if you see all the diagrams, there are three sets, A, B, and C. So if you observe here, what do you have? What is actually present? So if somebody gives you this kind of a diagram and asks you to interpret the meaning and write the operation between the sets, what will you say?
Excuse me, sir. Which diagram are you asking in particular?
The first one, going in the order, we'll go in the order. Look at the diagram, you take some time, interpret it. Okay, leave the first one as of now. Start with the second one. For second one, you have three sets A, B, C. And they have shaded a particular region, right? What does that shaded portion represent?
The common elements of set A and B.
They are the common elements of set.
A and
A,
B.
B, C.
It's C is not there.
A and B.
They are the common elements of set A and B.
Sir, but C is there,
C
right?
is there. Yeah, C is there. So here you have A. Yeah. Why did they write it as only A and B? Okay, we'll draw it. Okay, this is a universal set. This is set A. This is set B. What is this portion going to be?
Union set of set A and B.
Intersection of set A and B.
So it is A intersection B. So if I bring in a third set C, then what is it going to be? It is still going to be A intersection B only. Why is it so? Because this part of C is unutilized. Balaji, are you able to understand what I'm trying to say?
Yeah,
So
yes, sir.
This is how it looked. Right? I could have written it as A intersection B intersection C, had the diagram look like this with this part also utilized.
Oh,
But it is not utilized. That is the reason why it is only A intersection B. Guys, make sense?
yes, sir.
Yes. Now, using the same logic, what I would suggest is you try to draw the diagrams first. You try to draw the diagram. So break it into two parts and then try to draw the diagram. So A intersection, okay, leave it. You draw for this, no, A intersection C, you draw it. So since they asked for A intersection C, first draw set A, set C. Thirdly, draw the set B. Finished? Yeah. Now try for this one. So A intersection B union C. So what you do is first draw for, so you draw two-step diagram. First step will be for only B union C. Show it to me. So the operation says A intersection B union C. So how will B union C look like? I want to see that. So first take the universal set. Take set B. From B, I want all the elements. Take set C. From C, I want all the elements. So which portion will I take? Am I right? This is not B union C. So for this, I'm taking a third set where I'm interested to. So this is basically B union C. So if I take a third set like this and leave it, if I don't take any elements from there, then it is still going to be B union C. That's what this diagram is. That is what the first diagram is, B union C. Now to this B union C, we need to do the A intersection. So what should you take? So you need to take the elements from A and you need to take the elements from B intersection C. That is the meaning. Sorry, B union C. Because wherever you see intersection, what does it mean? It is and. Means the element should be present in the region of A and they should be present in the region of B union C. So which region am I going to consider? I'm only going to take, I'll use the black color here. I'm only going to take this region. Are you able to understand, guys?
Yes, sir.
So that is how this diagram came. Okay. Makes sense. See, this is what we are going to do throughout this exercise, understanding Venn diagrams and representing. Okay. This one minute. Yeah. So what about the next one? A intersection B union A intersection C. So we have all the region. We have A, B, C, all the three intersecting. So what is the meaning of A intersection B? A intersection B is this region. Correct. What is A intersection C? A intersection C is this region. A intersection C is this region. So I need A intersection B union A intersection C. So it is going to be the total region. It is going to be this total region, no? Am I clear with this?
Yes, sir.
All right. So with this, we will go to the next concept, that is difference of sets. See, mostly by names itself, you will be able to understand things. So the next concept is difference of sets. So the difference of the sets A and B in this order. So what do you mean by in this order? If I'm doing A minus B, order is important here. Okay, the difference of the sets A and B in this order is a set of elements which belongs to A but not to B. That's obvious, right? A minus B means I need to take only those elements which are there in the set A but not there in the set B. So if there is a scenario where they are intersecting, so in set A, I will have elements present here also, but those elements are a part of B also. So what should I do when I do A minus B? I need to remove them. So what will you
Should
get?
not consider the common region and only need to consider A.
Yes, you need to consider only this region. If at all they have intersection, if they don't have intersection, you will take all the elements of set A. You're able to understand? So symbolically, we write it as A minus B and read as, obviously, I told it. It is read as A minus B, right? So example 18, if I take A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 2, 4, 6, 8. If I ask you what is A minus B, so your eyes should look for only one thing. What is there in set A which is not there in set B? 1, 3,
1, 3, 5.
that's it. No, that is A minus B. Then what is B minus A? So what is there in set B but not there in set A? It
6. No. 8, 8.
is only element 8. So you're able to observe one thing here. A minus B is not the same as B minus A because order is very important. Clear? So that's all with this concept. With this understanding, let's try to do the example problems. E and O. It's E and O, no? Similarly, what is B minus V? What is there in B but not in A? Sorry, V. It is only A. Am I audible?
Yes, sir.
Yes, sir. So for 10 seconds or something, the video lagged, so we weren't able to hear what is.
I didn't speak anything because I changed my network.
Oh,
Now only. So V minus B is not equal to B minus V. right? So how do you write it in the set builder form? A minus B is equal to, write down this point alone. A minus B is equal to set of elements X such that X belongs to A, and it is a simultaneous operation. It's not happening individually. It is a simultaneous. That is why and X belongs to A and X does not belong to B. That is the meaning of it. This is how you write it in the set builder. Okay, you're clear with this?
Yes.
So we learned three operations, right? What are they? A intersection B, A union B, and A minus B, right? So among which, if you see, if you take A minus B, A intersection B, and B minus A, what are the three? A minus B and B minus A, both are differences, and A intersection B is the intersection operation. If you take A minus B, A intersection B, and B minus A, they are said to be mutually disjoint sets. The meaning of mutually disjoint set means whenever you take the intersection of anything, you will get a null set. So whenever you take the intersection of A minus B and A intersection B, you will get a null set. Whenever you take A intersection B and B minus A, you will get a null set, something like that. Right? Means nothing will be common in each of them. So this is what is called as mutually disjoint set. About this, you will learn more in probability. Okay, at that point, it will be important. So with the assumption that you're clear with the basics, shall we do the problems?
Yes, sir.
Okay, see, 1 minute. How many problems are there? 12 problems? No. So if our basics are good, 12 problems should not cross 15 minutes. 15 is very high. It should just be completed in 15 minutes. Shall we start?
Yes, sir.
Yes. So we'll go in the order. Balaji, starting with you.
Okay, sir.
Find the union of the following: X union Y.
X union Y is equal to 1, 2, 3, 5. 1, 2, 3, 5.
Ananya, next one. A union B.
A, E, I, O, U, B, and C.
O, U, B, and C. Yeah. Chitesh. A is equal to X such that X is a natural number and multiple of 3. So first you need to tell me what is the set X. Sorry, set A. X is a natural number and multiple of 3. So X is a natural number and multiple of 3 means it will be 3, 6, 9, 12, so on. It's an infinite set. What about B? X is a natural number less than 6. X
1,
is a
2,
nat-
3, 4, 5.
1, 2, 3, 4, 5. We don't take the 6 into consideration. Right. What is A union B?
1, 2, 3, 4, 5, and 6, 7, 8, 6, 9, 12, so on.
6, 9, 12, so on. That's right. Yeah, Balaji. Fourth
Yes.
one. A is equal to X such that X is a natural number and X belongs to 1 to 6, where 1 is not included, 6 is included. So what is set A?
Set A is 2, 3, 4, 5, 6.
Correct. What is B?
Set B is 7, 8, 9.
Correct. What is A union B?
A union B is 2, 3, 4, 5, 6, 7, 8, 9.
Correct. Ananya, easy one.
1, 2, 3.
1, 2, 3. Because A union null set is A. Correct. So you'll get A itself, which is 1, 2, 3. So second one. Chitesh, tell me. A is equal to A comma B. B is ABC. Is A a subset of B? You know what is subset? Okay. Is A a subset of B?
Yes, sir.
Yes. A is a subset of B. Then what about B?
A union B is A, B, and C.
Set B itself. So for the first one, answer is yes, because the set A is derived from set B. Right. Secondly, A union B, it is going to be the set B itself. Okay. Yeah, Balaji.
Yeah, sir. For the
A and
third
B
one, the answer is the set B itself.
A and B are two sets such that A is a subset of B, then what is A union B? It's the example you have it above.
Yeah.
Okay. Yeah. That will be set B itself. Correct. Ananya, tell me, ma. So A is 1, 2, 3, 4, B is 3, 4, 5, 6, C is 5, 6, 7, 8, and D is 7, 8, 9, 10. Find, what are they asking? A union B.
1, 2, 3, 4, 5, 6.
Second,
1, 2, 3, 4, 5, 6, 7, 8.
correct. Okay. B union C.
3, 4, 5, 6, 7, 8.
4, 5, 6, 7, 8. Fourth one, B union D.
3, 4, 5, 6,
Correct.
7, 8, 9, 10.
That's it. Okay. A union B union C. A union B union C.
1, 2, 3, 4,
1, 2, 3, 4.
5, 6, 7, 8.
Correct. That is fifth one, no? What about the sixth one?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
B union C union D.
3, 4, 5, 6, 7, 8, 9, 10.
That's it. Good. Fifth one, Chitesh.
Yes, sir. So first question, can you?
I'm rubbing this because it's simple. First question, tell me. You need to find the intersection. That's it. A intersection B. A intersection B.
Can you go to the first question? I cannot see the first question.
This one. Oh, from question number 1.
Yeah.
Okay.
Sir, for A intersection B, it is A and it's only A, sir. For
Lila, which one are you saying?
first one. No, they're asking A intersection.
Find the intersection.
Okay, sorry, I thought you wrote it here A intersection B. Sorry. So first one, it is 1.
1 minute. X intersection Y.
It's 1.
1.
Second one, A intersection B is A.
Only A, no?
Yeah.
Yeah, because here we have vowels and consonants. Yeah. What about the third?
Third one, it's only 3 because we are not considering 6.
Correct.
And fourth one, it is.
Fourth one, we wrote the numbers, no? 2, 3, 4, 5, 6, 7, 8, 9. So 2, 3, 4, 5, 6 in the first one, 7, 8, 9 in the second one.
So it is another set.
It's a null set. Fifth one,
Null
1,
set.
2, again a null set. That's it. Good.
Sir, in the previous question, for the first one, it's 1 and 3, right, sir?
3 is there, no? Yeah, it's 1 and 3. It is 1, 3. Correct. So that we missed. Okay, Balaji, tell me sixth one.
Okay, sir.
A is 3, 4, 3, 5, 7, 9, 11. B is 7, 9, 11, 13. C is 11, 13, 15. D is 15 and 17. Find A intersection B.
A intersection B is 7, 9, 11.
So 7, 9, 11. Correct. B intersection.
B intersection C is 11, 13.
Correct. A intersection C intersection D. What is A intersection C in the first place?
A intersection C is 11. Yeah,
Okay.
only
first
11.
have 11. What is there in
D. In D, we have 15 and 17, but 15 and 17 is not present in set A.
it's not present in set A intersection C. See, the A intersection C is 11.
Okay.
This is 15, 17. Is there anything common in them?
15, no.
First, A, what is A intersection C? A intersection C is only 11.
Yes.
So A intersection C is 11. You
Okay.
need to do the intersection operation between these two sets. Among 11, 15, and 17, is there anything common?
No.
So what is the answer? It's null set.
Null set. Okay.
Okay, what is A intersection C?
A intersection C is 11.
11. B intersection D,
B intersection D, null set.
null set. A intersection B union C. What is B union C in the first place?
B union C is 7, 9, 11, 13, 15.
What is A? 3, 5, 7, 9, 11. So if you do the intersection operation between them, what do you get?
We get 9, 11.
No, 7 you left, no? 7 is there.
7, yes, 7.
7, 9, 11.
7, 8.
7, 9, 11. Okay. What
Yes.
about A intersection D?
A intersection D is null set.
Okay. What is A intersection B union D?
Oh, okay. So first B union D is B union D is null set. So
There, B
A-
union. You're doing B intersection D is null set. B union D is not null set.
Okay. Oh,
Ah.
sorry. So sorry.
Ah.
7, 9, 11,
Hmm.
13,
Ah.
15, 17.
Okay.
And A intersection of this set is 7, 9, 11.
Correct. So 7, 9, 11 is the answer.
Yes.
Okay, you B. Ananya, you tell me. So what is A intersection B intersection of B union C?
A intersection B is
7, 9,
1 second, 7, 9. That's all.
no, 11 is there, no?
There's no 11 in B. So
B la irukke ma. This one is there, no?
they asked for D. Oh, you're asking the 9th question.
No, no, ninth one.
7, 9, 11.
7, 9.
B union C is 11, 13, 7, 9, 15,
7, 9, 11, 13,
15.
15. Okay.
Intersection of that is 11, 9, 7.
Okay. So what is the answer? 7, 9, and 11 is going to be the answer. Okay. Chitesh, you tell me the 10th one.
Yes, sir. Can you come down? I couldn't see it. 10th question, sir.
Yeah, this one.
A union D. So it is null set, sir. They don't have anything.
Again, you're doing the same mistake. They asked union.
Yes, sir. They don't have anything in common, sir. A and
You're
B
doing
does. Oh, sorry, sir.
Yeah.
That it is intersection. 3, 5, 7, 9, 11, 15
3,
and
5,
17.
7, 9, 11.
15 and 17.
Correct. Intersection B union C. Sorry, B union C, tell me. B union C
Union
is
C is 7, 9, 11, 13 and 15.
what is the intersection between them?
Intersection is 7, 9, 11,
7, 9, 11?
13 and 15.
13 common earlier.
Okay, sorry, 15.
7, 9, 11 and 15 is the answer. Okay, 7, 9, 11, 15 is going to be the answer, right? So I hope it is clear, no? Can I rub this?
Yes, sir.
Seventh one. A is equal to x such that x is a natural number, and B is equal to x such that x is an even natural number. And C is such that x is an odd natural number, D is such that x is a prime number. Okay. So I think Balaji, it's your turn, right?
Yes, sir.
So
So
tell me
set
the set first.
A is 1, 2, 3 till infinity,
Okay.
and set B is 2, 4, 6, 8 till infinity,
Okay.
and set C is 1, 3, 5, 7 till infinity, and set D is 2, 3, 5 till infinity,
2, 3, 5,
7
7
till infinity.
till infinity. Okay.
So first
So
A
intersection B.
intersection B is 2, 3, no, sorry, not 3, 2,
Correct, right? 2, 4 actually.
2, 4. Yeah, A intersection B is set B itself.
That's what it said B itself. Right.
Yes, sir.
Similarly, what is A intersection C?
A intersection C is set C itself.
A intersection D is
A intersection D is set D itself.
yes. Now, Ananya, you tell me.
B intersection C is null set.
Yes, because here it is even, here it is odd. You will not have any numbers in common. What about B intersection D?
B intersection D is 2.
It's going to be only because everything else is going to be an odd number. But C intersection D,
C intersection D is 3, 5, 7, 11, and so on.
so it is going to be 3, 5, 7, 11, so on. Basically, is it not set D minus B?
Yes,
No,
sir.
no, it's,
Yes,
no, it's
because
not.
4 is present in D.
Yeah. Set D minus B. It works, no? So set, you are writing the set D. From that, if you remove B, what is the common element you are removing? 2. Okay, just another way of writing it.
Sir, what did you say, sir? Can you repeat?
See, from set, it's basically set D only. C intersection D is basically set D only. But from D, what is the element I need to remove?
2.
That's what I do. D minus B.
D minus B, sir.
B. Yeah, this is what I wrote.
Oh. But sir, in set D we have 4, right, sir?
Let it be. No, we are going to remove all those elements.
Okay.
Yes. Now, Chitesh, you tell me what do you mean by disjoint sets?
Sorry, sir.
Yeah, what do you mean by disjoint sets? So they asked which of the following pairs of sets are disjoint? So when are the sets said to be disjoint? When the intersection between them is a, sorry?
Null set.
Correct. So if you observe this, A is equal to 1, 2, 3, 4 and X is a natural number between,
4 less.
so between 4 and 6, where 4 and 6 both are included. So what is the set going to be?
4, 5, and 6.
Correct. Are they disjoint sets? Because you have a common element. 4. AIOA and CDF.
They
sorry, CD, E, F.
They have E as an intersection.
X is such that X is an even number and X is an odd number.
They
It's
have a
a-
null set.
Their intersection is a null set. Right. Ninth one. Yeah, Balaji, tell me. A is equal to 3, 6, 9, 12, 15, 18, 21, or the first 7 multiples of 3. B is equal to 4, 8, 12, 16, 20, the first 5 multiples of 4. C is equal to 2, 4, 6, 8, 10, 12, 14, 16. The first 8 multiples of 2. D is equal to 5, 10, 15, 20, the first 4 multiples of 5. Right?
Yes.
Find A minus B.
So for A minus B, we get all the elements in set A except 12.
Is it all? Correct. All the elements, that is, you will get 3, 6, 9, 15, 18, 21. You will not get 12 alone.
Yes.
So what is A minus C?
A minus C. In A minus C, we will exclude 6. Yeah, we will only exclude 6 from set A and write our rest all elements.
You are missing some other element.
Okay, 6 and 12.
Yes, you need to remove 6 and 12.
Yes.
Correct. So what is
And
A
right.
minus D?
A minus D. In A minus D, we will exclude 15. We'll only exclude 15 from A.
Correct. Only exclude 15. What is B minus A?
B minus A. From B minus A, we will exclude only 12. Only 12 in set B.
Correct. That's right. Ananya, you tell me the remaining 4.
C
B minus A.
A, the answer is 2, 4, 6.
C. Oh, okay. Sorry. C minus A. Correct. 2, 4.
2, 4, 8, 10, 12.
10.
10, 14, and 16.
Correct. What is the D minus A?
D minus A is
Everything in D except
15, except 15.
10. Oh, D minus A. Sorry. Yeah. Everything in D except 15. Correct. What is B minus C?
Everything in B except 20.
Except 12 and
No, 12 is fine.
no. Everything in B except
20.
20.
B minus D is everything in B except 20.
Yes. So what is C minus B? Yeah. Let Chitesh do that. The last 4 you tell me.
So can you hear me?
Yeah.
So C minus B will be 2, 6, 10, and 14.
Okay.
And D minus B will be 5, 10, and 15.
Okay. No. B minus B. You will have 5, you'll have 10, you'll have 15. 20 is to be removed. Now C minus D.
C minus D is 2, 4, 6, 8, 10, 12, 14, and 16. The set
But
C
10 is there. No. 10 is common, no?
Oh, yeah, 10 is common. So 2, 4, 6,
2, 4,
8,
6, 8.
12, and 14, 16.
So what is D minus C?
D minus C is 5, 10, and 20.
D minus C, 10 is common, la? D and
Yeah,
C.
sir, 5, 15, and 20.
Okay. 5, 15, and 20. That's right. So you guys understood that. Okay. Balaji, 10th one.
Yes, sir.
Hmm.
So x equal to ABCD and y equal to FBDG.
Correct.
So x minus y is
A.
everything in set X except B and D.
So what should I write?
A, C.
Yes. What about y minus x?
For y minus x, we have F and G.
X intersection y.
For x intersection y, we have B and D.
Correct. Yeah, Ananya, you tell me this. If R is a set of real numbers, Q is a set of rational numbers, then what is R minus Q?
So R is,
Real number.
should I
Q,
write this, tell the set?
you need not tell the set. It's a theoretical question. So you have a real number set. From the real number set, you're removing the rational number set. What will you get?
Irrational.
That's the answer. So they are the irrational numbers. 12th one. State whether each of the following statement is true or false. Justify your answer. 2, 3, 4, 5, and 3, 6 are disjoint sets. Jitesh,
Yes, sir.
are they disjoint?
No, sir. They have 3 as common.
Yes. No. So A, E, I, O, U, and A, B, C, D are disjoint sets.
No, sir. They have A and A as common.
They have A as common. Yeah, 2, 6, 10, 14, 3, 7, 11, 15.
They are disjoint sets.
They are disjoint because one is even and the other is odd. So 2, 6, 10, and 3, 7, 11.
They are also disjoint.
They are also disjoint. So null set. So S and S. That's right. So I hope you could understand. No, it's simple,
Yes, sir.
right? So the next part that we are supposed to discuss is the complementary of a set, and we'll be seeing about these laws, the De Morgan laws and everything. And then we'll solve this. And the last part of the chapter is the practical problems based on union and intersection of set. That is, you will have statement-based problems. We need to draw the Venn diagram and try to solve it. That is also simple. See, if you see, I've already given you the formula of how it has come. You already know this. This is the thing that we saw, no? Number of elements in A union B is equal to N of A plus N of B minus. So now, since you know the Venn diagram and the basics are strong, we'll be able to complete this chapter, right?
Sir, but that particular formula is deleted, the ma'am said.
It is, I'll teach you that. It's needed for probability. This year they'll delete 12th standard, you'll need it for probability. That time it should not look new. It will not take much time, okay?
Okay, sir.
So deleted also, if I feel it is important, okay, if it is independent topic only, I'll leave it. If it has connection with some other chapter or some, even a smallest of some other topic, I'll teach you. Okay. And you have to learn it. In my test, I'll test you. In the, whatever test you are writing in the institute, you will be asked that question. Don't tell me that it is deleted. Okay.
Okay, sir.
So these two parts, I'll do it in the next class. In tomorrow's class, we'll finish it off. Okay. Any other doubt from today's class?
No,
I
sir.
think you have, because you guys only solved it. Okay. So I'll see you tomorrow.
Thank you, sir.
Thank you, sir.